Hi, I'm Mike Joseph of the New Bedford Regional Pilots Association. Welcome to our show, The Pilot's Log. Today we're going to be showing you the B-24 story about World War II, what the country went through to generate aircraft to win the war. Hope you enjoy the show. Thanks for flying with us.
This is the story of Willow Run, one of the Ford farms that virtually overnight became the largest aircraft plant that had ever been built. A story that now can be told in full. And this was Willow Run's product, a giant flying machine for which the plant was so carefully tooled that it could produce one every 55 minutes. This is the Army Air Force's Liberator heavy bomber, the ship that made headlines and was affectionately known among flyers as the Lib. This great aircraft is 110 feet from wingtip to wingtip and 67 feet 4 inches from nose to tail. Powered by 4 1,200 horsepower air-cooled engines, the Lib can carry 10 men, 4 tons of bombs, and 5,000 rounds of machine gun ammunition at better than 300 miles per hour at high altitude. The B-24, as it is officially designated, can fly 3,000 miles non-stop. And as the pilot moves the control tower and prepares to bring her down, we will soon see for ourselves how this modern miracle of mass production has been performed. Okayed by the tower and lined up with the runway, we are bringing in 20 tons of bomber at better than 100 miles per hour. On solid concrete. The pilot again calls the control tower and is assigned a position on the apron. And as we taxi to this berth, we pass just part of a day's production waiting to be tested by Ford pilots. Flags wave our pilot to his position, and we are grounded at fabulous Willow Run. At the entrance to the administration building, 1 mile away from the landing apron at the other end of the plant, this plaque proves that the Army Air Forces and Ford were ready when war came. Dedicated June 16, 1941, 6 months before Pearl Harbor. In offices of the Army Air Forces and in that of the Ford superintendent, a close check was kept on the movement of all bomber assembly lines with this master board. Numbered, movable models show the step-by-step progress of the nearly 100 bombers which were always progressing down through the plant assembly lines. Bomber and hour production made necessary the erection of a detached warehouse covering 11 acres to house and handle raw materials. In this vast space, 785 totally different items were stored. There were enough materials here and in the plant at one time to build 1,000 Liberators. Here you would find sheet aluminum, aluminum bars, coiled aluminum wire, and virtually every other known form of this lightweight metal, for 85% of a Liberator's 20 tons is aluminum. This was the step of construction. Aluminum sheets were cut into proper sizes for handling in the plant's presses and forming machines, such as this great battery of presses which stamped out parts for the B-24. Some of these, the same presses Ford uses to make bodies and fenders for automobiles, were loaned to Willow Run. Because of the great variety of parts that go into a bomber, nearly 15,000 dies had to be constantly rotated through these presses to maintain a sufficient stock of parts on hand. Before these aluminum sheets were fed into presses, they had to be sprayed with a lubricant to prevent scratching and to help the metal flow in the dies. In this operation, 3 presses are seen shaping a wing bulkhead. Because of the wing taper, 57 different shaped and sized bulkheads were made for each wing. These presses soon produced enough of this size for many ships, after which the dies had to be changed. So the die changing operation went on continuously. Since these planes were to be flown over salt water, in the tropics, far north, all over the world, individual parts had to be treated to protect them from the elements. Racks like these dip 52,000 shining pieces, plus 4.5 tons of rivets every working day. And speaking of rivets, 400,000 went into every liberator, and these too were produced at Willow Run. This plant produced more than 400 sizes and 13 varieties of rivets, carefully checked by inspectors. In sharp contrast to small rivets are these 250-pound landing wheels shipped in, ready to install. Just a tube of this tire weighs more than the complete tire and tube on the average family car. The wings and fuselage took thousands of feet of stringers, the ribs of the body, and these were shaped on miniature rolling mills such as this. Each roller adds a bend in the stripped aluminum. Then the length is sliced off. After treating, stringers went to punch presses, where as many as 312 holes were punched with one stroke, through which rivets later held the aluminum skin. Practically everything in a bomber had to be curved in one direction or another. The revolving action of the die bends the metal to the needed shape. This peculiar looking operation was typical of many at Willow Run. At this station, heavy stock was rolled into a circular track for a power gun turret. And this later was machined to fine tolerances so that the guns could swing smoothly and swiftly in combat action. Aluminum tubes made up the arteries of the lib. These tubes carried gasoline, oil, hydraulic fluid, oxygen, compressed air, fire extinguishing fluid, steam, de-icing solution, screening smoke, and antifreeze to various parts of the ship. More than 1,700 different tubes were installed in each B-24 to feed the 12 different control systems. Straight pieces of tubing were cut, bent carefully, flanged, degreased, treated to prevent corrosion, prepared with proper fittings and inspected. Each was identified with colored tape. Instead of putting individual tubes into the bomber, Ford's mass assembly technique called for making them up into clusters, which were made in special jigs and fitted into the bomber in entire units. And here you see workers assembling the pre-bent tubes into one assembly unit. These clusters, assembled with other sections, made up the bomber's complicated plumbing system. Basically, Willow Run's manufacturing system was like that of the Ford automobile plants. This was the key to the secret of building one bomber every hour. And these were handled very much like automobile assembly lines, where cars are also divided into major components: the frame, the engine, the wheels, and the body, all mated on the final assembly line. Like the